Kuzambola, Bhutan e-learning project welcomes you to this lesson. I am Sherab Jatso, a teacher at Yangchen Gasil Middle Secondary School in Thimphu. This is a science lesson for Key Stage 3, which includes classes 7 and 8. Well, in this modern era where science and technology has advanced to such a great height, electricity is one of the important forms of energy where people use it at homes, industries, factories, schools, and in many other places. Well, we are so dependent on electricity that even if there is no power supply for a while, we feel really handicapped. Electricity or electrical energy is also said to be one of the clean form of energy, but it is also dangerous if we do not use it properly, or in other words, if safety measures are not taken. In today's lesson, we are going to look deeper into electricity and try to understand some of the very important terms like voltage, current, resistance in electricity. And we are also going to explore the relationship between voltage, current, resistance. We are going to look at static electricity and some of the natural electrostatic phenomena. And towards the end, we will also look at two different types of current, that is direct current and alternating current. Well, since this is an educational lesson, we have to know some objectives of today's lesson. So, objectives of today's lesson are, by the end of today's lesson, you should be able to, number one, explain current, voltage, and resistance in your own words. Number two, you should be able to establish a relationship between current, voltage, and resistance. In a way, you should be able to state Ohm's law clearly. Number three, you should be also able to describe electrostatic phenomena and explain what is electrostatic, or you can say what is static electricity. And towards the end, number four, you should be also able to differentiate between direct current and alternating current. Okay, if you are ready, let's begin. But before we really go into today's lesson, it is important for you to recapitulate or recollect some of the important concepts that you have learned in your lower science classes. The concept like atoms, the concept like proton as a positive charge, the concept like electron as negative charge, the concept like force and frictional force that actually opposes the motion between two objects. So these small concept will be very useful to understand today's lesson very clearly. Okay, my dear student, if you are ready, let's start. To start or to begin, I'd like to ask you a question, and the question is, what is current? Yes, what is current? You must be racking up your brain and trying to come up with a definition. Please do so. Current, as you have studied, or as you must have studied in your lower classes in bit and pieces, current is a rate of flow of charge, that is, number of charge flowing through a conductor in given amount of time. So if you have a conductor and A and B, and if you have a conductor, the rate of charge flowing from end A of the conductor to end B of the conductor, end A of the conductor to end B of the conductor in given amount of time is called as current, and it is represented by symbol capital I. And the unit to measure current is called as amperes, and it is represented by symbol capital A. Now you must be wondering what kind of device or electrical device would be used to measure current. If you are wondering, it is called as ammeter. Yes, it is called as ammeter. Now the second question, what is voltage? What is voltage? Or in other words, you also called it as potential difference, represented by symbol capital V. As I have mentioned earlier, current is a rate of flow of charge through the conductor. Now, Voltage is the driving force, electric force that pushes the charge from one end to another end. I'll repeat it once again. Voltage is a driving force or electric force that makes the current to flow through the circuit or that push the charge from one end to another end. And the unit to measure voltage is volt, represented by symbol V, and it is measured in a device called voltmeter. Now, the third question, what is resistance then? Yes, what is resistance? Represented by symbol capital R. When charge flows from one end to another end, or when potential or driving force push the charge from end A to end B, the obstruction offered to the flow of current, or the resistance, the blockage offered to the flow of current is called as resistance. And it is measured in a unit called ohms, represented by Greek letter omega. And it is also measured in a device called ohm meter. So, well, that brings us to the end of defining current, voltage, and resistance. Now, let us look at the relationship between these three variables. So, in a scientific world, people have been trying to establish relationship between different variables, and especially when it comes to establishing the relationship between current, voltage, and resistance. German physicist George Simon Ohms establish a very perfect relationship between current, resistance, and voltage, and in scientific world this relation is known as Ohm's law. According to Ohm's law, it states that the current flowing through a conductor is directly proportional to the potential difference applied across its end, provided the physical condition like temperature and pressure remain constant. I'll repeat it once again. The current flowing through a conductor is directly proportional to the potential difference applied across its end, provided the physical conditions like temperature and pressure remains constant. So that is, as you can see it clearly here, V is directly proportional to I. Voltage or potential difference is directly proportional to current, right? If you remove the proportional sign, the equations become VE is equal to IR. VE is equal to IR. This is the mathematical representation of Ohm's law. Voltage is equal to current times resistance, and R is the proportional constant. Now, if you want to make I subject, or if you want to calculate current, your equation becomes I is equal to VE divided by R. I is equal to VE divided by R. If you want to calculate resistance, R is equal to VE divided by I. Voltage divided by current. Resistance is equal to voltage divided by current. So these are three important mathematical formula that will be useful to you to solve some problems related to Ohm's law. Hope you are clear with these three questions. If you are clear, let's look at some problem. Okay, some problems related to Ohm's law are: number 1. A conductor carries a current of 1.2 amperes and offers a resistance of 5 ohms. Calculate the potential difference or voltage across the conductor. Now, when you see such kind of problem, what will you do? As always, you have to list the given variables, and in this question, the given variables are current I is equal to 1.2 amperes, resistance R is equal to 5 ohms, and voltage is not given. So what do you know? You have already learned the formula, that is voltage is equal to current times resistance. That is V is equal to IR. Substituting the values, V is equal to 1.2 times 5. That is voltage is equal to 6 volts. This is your answer. Okay, let's look at question number 2. What is the ammeter reading in the circuit given below? So if you look at the screen, you will see a circuit diagram. And if you look at the circuit diagram, you will see that resistance is given as 16 ohm and voltage or potential difference as 12 volt. So ammeter reading, that is current flowing the circuit, is not given. So you have to list the given things, that is voltage is equal to 12 volt, resistance R is equal to 16 ohms, and current is not given. So if you want to find or calculate current, you have to use the formula I is equal to VE by R. That is, substituting the value, you get 12 divided by 16, that is equal to 0.75 amperes. 0.75 amperes is your answer. Now let us look at third problem. Calculate the resistance offered by a heater if the current flowing through it is 3 amperes when a potential difference of 15 volt is applied across its end. So as always, list the given things. Given current I is equal to 3 amperes, voltage V is equal to 15 volt, resistance is not given. So from the mathematical representation of Ohm's law, we know that V is equal to IR. Therefore, R is equal to voltage divided by current. So that is R is equal to 15 by 3, that is 5 ohms. With this, we are done with solving some simple problems related to Ohm's law. Hope you are enjoying the lesson. Okay, as a brain break, I would like to give a very interesting statement related to electricity. That statement is, electricity is a very good servant but a bad master. You got it? What did I say? Electricity is a good servant but a very bad master. What does it mean? My dear student, if you use electricity properly, electricity serves us to do our things in lot simpler ways. But if you do not take safety measures, if you do not take precautions while using electricity, it may cost our life also. It is dangerous. It is very, very dangerous. So please keep this statement in your mind. Now, let us look at next topic, static electricity. My dear student, have you ever experienced crackling sounds or some sparks while you try to remove your woolen clothes? Have you ever played with a ruler, rubbing to your head and bringing near the pieces of paper whereby you saw papers getting attracted to the ruler? Have you ever experienced your hair rising up when you try to remove a woolen cap? If you have experienced that, probably you have actually produced certain static electricity. So static electricity, as the name suggests, is the charges accumulated over a given material when you try to rub two different substances. So that accumulated charge act as a static electricity. Static electricity, as name suggests, is the charge that remain accumulated over a given material. Now, did you ever wonder how charges are produced? How static electricity is developed? If you are wondering, here is the solution. Yes, in order to understand that, you have to go to the atomic model. In an atomic model, as you have studied in your lower classes, atom consists of protons, neutrons, and electrons. These are the subatomic particles. So proton and neutrons are in the nucleus of an atom, and electrons are revolving in the shells of an electrons are revolving in the shells around the nucleus. Atom by nature, as you have studied in your lower classes, is a neutral entity. That is, nucleus have a positively charged proton and surrounding it are electrons which are negatively charged. So there are equal number of protons and electrons, meaning there are equal number of positive charge and negative charge. So atom is a neutral entity. But what happens if you rub two different materials. Materials are made up of atoms, so when you try to rub two different materials, due to the frictional force, there will be transfer of electrons taking place. Transfer of electrons taking place. So the body or object which loses electrons become positively charged, and bodies or materials which receive electron becomes negatively charged. So these charged body are the source of static electricity. You must be wondering, what are some of the natural phenomena? Or what are some of the interesting things happening? What are some of the natural things happening due to static electricity? Or in other words, we also call this as electrostatic phenomena. When we talk about this, perhaps one of the interesting natural electrostatic phenomena is lightning. Yes, lightning. Have you ever experienced lightning? Yes, you must have experienced it. You must have experienced it. How did you feel? Are you feeling very interested? Or are you feeling very scared? Why do you think lightning is happening? If you are wondering, let us explore it just now in this lesson. Okay, now let us try to uncover what is actually happening or how lightning is happening. In a cloud, water, air and dust particles collide with each other as they move, because in atmosphere the objects or molecules there, particles there are in constant motion. So electric charges are developed as they collide with one another. The clouds get filled up with electric charges, negative charges in the lower portion and positive charge in the upper portion. A layer of air in between will act as an insulator. When huge amount of charge builds up, electric discharge takes place between two oppositely charged clouds or between charged clouds and the surface of Earth. This electric discharge, release of electron, is what we see as lightning. I repeat, this electric discharge or release of electrons is what we see as lightning. Okay, my dear student, is it interesting? Yes. Now, lightning can be dangerous because it carries thousands of voltage energy with it. Because it carries thousands of voltage of energy with it. For a mere human being, more than 110 voltage is enough for us to get killed or get electric shock. So if lightning carries thousands of voltage, it is very, very dangerous. So as a science student, we should also know some precaution or safety measures that you must follow when there is a lightning. Safety measure number 1: avoid going under tall trees. Avoid going under tall trees, because tall trees are a good conductor. They can conduct electricity and you will get electric shock if you stand under tall trees. Number 2, avoid touching metallic object, and especially like TV antenna. TV antenna which are placed at the top of the building. So they may receive the charge and it will conduct the charge. So it is very important for you not to touch metallic conductor during lightning time. Number 3, if you have your electric gadgets like mobile phone, television, laptop, refrigerator and many other appliances connected or in use, it is safe for you to plug it off, because high discharge of electron or high flow of voltage may destroy your electrical appliances. Number 4, if you are walking using an umbrella, you should use an umbrella which have wooden or rubber handle. If it is a metallic handle, it will conduct electricity and you will get electric shock. If you are lying in a big plain field not knowing what to do, the best alternative option for you is to lie flat on the ground, because charge will be conducted through the earth. And last but not the least, if you are traveling in a car, The best option for you is to stay idle in the car by closing your windows. If you are showing your hands out or if you are touching the parts of the car, there is high chances that you will get electric shock. So, my dear student, as a science student, if your parents are not aware of such safety measures or precautions, please inform to your parents also. Now, another natural phenomena occurring due to static electricity or electrostatic potential is you must have experienced a mild shock when you come out of the car, when you open the car's door. I have experienced it several times myself. What is actually happening? The insulator in the car when you as you drive are in constant rubbing or they are in constant touch. So there is an accumulation of a charge over the body of the car. So when you get out of the car and when you open the door of the car, sometimes you get a mild shock. Now with this, we come to our last topic for today's lesson. And the last topic is types of electric current. There are two types of electric current, that is direct current and alternating current. Direct current represented by DC, and that the symbol used to represent direct current is this one, and alternating current represented by alternate AC, and the symbol used is this one. Direct current are the current which flows only in one direction, whereas alternating currents varies in their magnitude and direction with the change in time. So that's why it is also given the name as alternating current. The source of direct current are like cells, batteries, and DC generator, whereas the source for alternating current is AC generator and the main electric supply that we have. The electricity supply that you have at your homes, schools, offices are all alternating current. And if you want to get a clear picture, this is the circuit diagram which shows the source as direct current, and this is the circuit diagram which shows the source as alternating current. So with this, let us summarize what you have learned in today's lesson. In today's lesson, in the beginning, we will learn about current, voltage and resistance. What is current, what is voltage, and what is resistance. And then we try to establish the relationship between these three variables through a law known as Ohm's law. And we solve some problems related to Ohm's law, and after that we look at static electricity and some electrostatic phenomena occurring in nature, and towards the end we looked at two different types of current, direct current and alternating current. Now the last section for today's lesson is for you to explore. Okay, to explore, question number 1. Figure given below shows two circuits, circuit X and circuit Y. Which of these circuits offers greater resistance to the flow of current? Explain the relationship between the current and the resistance in the circuit. So if you look at circuit X, you will see that voltage is 6 volt and current is 1 ampere. And if you look at circuit Y, you will see that the potential difference is 6 volt and current is 2 amperes. So you have to make out which one will offer greater resistance. Question number 2. Doji is in need of a large amount of current in order to run his machine, but he's not able to increase the current. So using the knowledge gained from today's lesson, what advice would you give to Doji to increase the current? So this is where you can use the concept that you have learned in today's lesson and give advice to Doji. Final question in Explore section, question number 3. Identify one common electrostatic phenomena other than the ones that we have discussed in the lesson and describe how static electricity is developed. This is all for today's lesson. My dear student, thank you so much for being a very good student. Hope you enjoyed the lesson. If you have any difficulties, please go through the textbook, consult with your subject teachers, and discuss with your friend. I wish you happy learning. Thank you.